Welcome back, 7 Caillou Ninjas. This is Thinkful, Object Drills, Quarks. Background, you're modeling the interaction between a large number of quarks and have decided to create a quark class so you can generate your own quark objects. Quarks are fundamental particles and the only fundamental particle to experience all 4 fundamental forces. Your task. Your quark class should allow you to create quarks of any valid color and any valid flavor. Note that these are represented as strings here. Every quark has the same baryon number, which is 1/3, and every quark should have an interact method that allows any quark to interact with another quark via the strong force. When 2 quarks interact, they exchange colors. Note the example. We instantiate a quark, call it Q1, access its color, and you get the string red. You do the same thing after constructing a blue quark with strange flavor, is what they called it. Access its color, it's blue. You check this baryon number, you get that 1/3 value. Finally, you call Q1 interact with Q2. Print their colors again. Note that Q1's color is now blue, it was red before, and that Q2's color now is red where it was blue before. So that's the idea. Simple challenge, but I like this because it's kind of continuing in the line of making our own classes, which when you get out in the wild, this is what you're going to be dealing with. Lots and lots of classes, big collections that interact with each other. It's not going to be these single throwaway problems that we see in these sandbox coding challenge environments. So this is good exercise. You know what to do. This is your time to have a go, and then come on back when you're ready. Okay, so I'll get into it. First things first, usually when I make a class, I like the constructor to be at the top. And while they didn't talk about the constructor in the instructions, we could see it's kind of implied here, right? This isn't an empty constructor, right? It's expecting, when it creates quark objects, 2 values, one representing the color, one representing the flavor. And you can see that too if you go down to the sample test over here, right? When they make their quarks, it's the color and the flavor. So we're not going to get away with something like this. You know, when you make a constructor, it's simply the public keyword and the class name. And we can't have an empty constructor, right? We need to know this information. We don't set it later, we set these values when we create the quark object. So that's sort of, it's sort of implied then that we should make our constructor take these values. A color and a string representing a flavor. Now, they use strings here. In real life, I would prefer to use in enumeration like we've seen before instead of these string values, but we'll stay with what they have because they're the ones who made the tests, and certainly we could adjust the tests here, but we don't have any control over them when we run the large attempt, right? So they're going to use all of their assumptions. So let's stay with that. Okay, so what do? Well, we know that when we pass these values, it's going to set these properties that quarks have, color and flavor. So let's make those properties. I will say public, again, we're using strings, color, and I'll set it up as a property, which we've used in the past. That's where you have these accessors. Get, meaning anyone can publicly access this value, but they won't be able to set it. We can only set the color internally because I added this private keyword here. You don't need that. If I did it like this, then anybody could set the value too. But I don't want that, right? To me, it didn't make sense that anybody could willy-nilly change the flavor. Or in this case, the color. We're going to make a flavor property too, right? Same kind of thing. Ooh. Flavor, there we go. Okay, good. So we know it has those two properties, and once we have these in place, we could simply say color equals color. Just assign the values that the constructor brought in. Okay. Oh, excuse me. Okay, good. We've got that. What was the other property that we had? We had this baryon number, right? And what's unfortunate about this is you'll notice the way they access this down here in their tests. They're actually doing it from the Q2 instance. And what I don't like about that is that it says every quark has the same baryon number. So why do we need to make a copy of the value 1/3 for every object? Imagine we made tons of these quarks. We don't need that. It's the same across all of them. So really what I would do if I were implementing this myself, I'd make it static. And we've talked about static a little bit, and the way I like to oversimplify it is that I think of it like turning off object-oriented programming. We know C# is an object-oriented programming language. And when you see static with a property, it's like saying, okay, this isn't a property of any specific instance of a quark, right? It sort of applies to the class as a whole. And in that way, it only makes one value for it. Baryon static, and they want some double value, you know, or you could set it up like a constant, you know, it seems to make sense as a constant there. But anyway, 1/3, and see how they had the D down here? That's just sort of saying that it's a double value, because if we just do integer division, right, 1 divided by 3 with integers, that returns 0. Because there's no 0.333 in integral values, that doesn't make sense, so it just kind of gets truncated down to 0. So yeah, the D there. But you'll see that if I went and tested this, and maybe I'll do that once we get it complete, that you're going to get an error because you're accessing it from a particular instance, and static is saying this doesn't apply to any specific instance. It's class wide. It applies to the whole class. So, oops. I don't like that they did it this way, and I wanted you to be aware of that, but we'll play along as usual. Public double. Okay, so we got the baryon number. That was another property. Good. What else did we have? We had this interact method, right? Let's do that. Public. We want this accessible, right, to our tests. We're making this public. This isn't some work we're doing behind the scenes. This is behavior that we're offering to our clients. So we're making it public. Doesn't need to return anything, right? It's going to do a color swap. And then interact method. And we see that it's going to take another quark object. Let's see if they showed it here. See, Q1, call interact on Q2. That's how we're going to use it. So we know this takes another quark. I'll just call mine other. You can name it whatever makes sense to you. Okay? And so what do? We have to swap colors. We could do a simple swap here. So the way I'm going to do this, I'm going to set up a temporary variable. I'll say my color equals color, right? And that's just sort of storing the current color of this quark object that we're dealing with, not the other one, the first one. So Q1 in this case, right? Or I'm sorry, we're on Q1. It's going to store its color because we're going to overwrite that value. And if we don't store what the original value was, we won't have it to assign to Q2. So then I could say color equals other color, right? And this is where our color was now overwritten, but we need to assign back to other as well. So we could say other color equals my color. That was that saved value that would have otherwise been lost. So I think that's all there is to it. Let me see what else we have. I think those were all the details. Let's go ahead and run it. We'll find out quickly if we did something wrong, right? Green, good. Okay, good, we're clear. I'll show you a couple things just to demonstrate. If we get rid of this D, right, I think that's going to come out wrong. It's going to be like 0. Yeah, test failed. Expected 1/3, right? But it received 0, 1 divided by 3 with integer math. So yeah, let's keep the D there. And then static, right? I just want one copy. I don't want a copy of 1/3 for every quark object that we create. Let's see what happens when I do this. Member quark baryon number could not be accessed with an instance reference. Qualify it with a type name instead. So what they were looking for us to do was, instead of Q2 baryon number here, with static properties, you would just use the class name. You would say quark baryon number. And see, it worked in that case, right? Because I use quark. I wish we could finish the problem that way, but I'll go back to what they had. But yeah, I mean, you could even set this up as like a constant, you know. So that's how I'd do it if it was the same value for every quark. But we'll go back, double. Okay, anything else? Yeah, the other thing that I think might be helpful to note is you might be wondering why this worked, right? I think we've talked a little bit about pass by value, pass by reference here. And the difference being is that this quark class that we made is a reference type. Any of the classes we make are reference types. So when I get an object, these changes are persisting, right? When I assign others color, it persists through this method because it's a reference type. It has the address of the quark where this data resides in memory. And so when you tweak it, you're tweaking the actual object. And this is distinct behavior from pass by value that we'd seen with integer values, where when you pass an integer to a method and you manipulate the integer in the method, those changes don't persist because you were given actually a copy of the integral value. You were not given the memory address where the integer resides. So any changes you make to the copy are sort of lost. They don't affect the actual data stored in the original memory location. And we can demonstrate that just to highlight the difference. We could make a method like public void pass by value test. Let's say int I. And for this, let's just we'll print the value I equals I. Let's say I equals just some value. We'll print it again. Now I'll use this interact method because I know it's going to get called to use this. And I'll just say int I equals 7, just some different value that you could see, right? And I will pass it to our method. And let's use those print statements here too so you could see everything. So you're going to see it before call. I'll say in pass by value test. Just trying to make these a little more obvious where they're coming from. After, and then we'll put 1 after here. Okay, so now you'll be able to uniquely identify each of these. And when I do this, right, we should see different behavior. We should see that when after our call here at the end, I should still be 7. That was not the case with our reference type though, right? These changes persist. After the interact, when you later call, see, you call interact here, and then you're later checking the color, right? That color change persisted, but we should see here it does not. So I expect we'll get I equals 7 before call, then we'll hit pass by value test, jump in here, it'll say in pass by value test, I still equals 7, right? We haven't modified it yet. Then we set it to 12. Here I would suspect it to say I equals 12, and then after the call it should say 7 again. So something like 7, 7, 12, 7. And if we test that, oh, console, yep, you got to use the system namespace for console. We didn't define that, did we? Okay, let's expand this and see our print statements. Okay, yeah, before the call 7, at the top of the method, once we're inside, it still equals 7. Remember, then we had a line to set I to 12, and that was confirmed here that I was indeed set to 12. And then notice after we exit that method, though, our original 7 value was preserved. So you could see that's definitely different behavior, and it's kind of confusing to beginners because it all just looks the same, right? It just looks like a method parameter, right? And you somehow just have to know that one's a value type and one's a reference type, and that information is all accessible online. You can search, you can Google right now and say what are the value types, what are the reference types, and it'll tell you. But yeah, it's kind of one of those unfortunate things that you usually, when you're a newcomer, you don't discover until something's very wrong and you're very confused, and you finally get to that. It's unfortunate that it's not a little more obvious, I guess, but that's why I'm here trying to point this stuff out to you now. So I'm going to go ahead and get rid of this. This has nothing to do with the actual solution. And then I'll go ahead and submit this way to collect my points. I think I fixed it. Let's attempt. Good, there's green. I'll go ahead and submit mine this way. So yeah, some good work with classes there. You're going to want to get comfortable making your own classes. That's a very important first step to programming. You don't want to shy away with this. I know some people, when they're brand new, they shy away from that. They don't want to make classes. It's scary and confusing. They tend to just cram everything into a big main method, but you don't want to do that. It doesn't have to be scary. It's not scary. Embrace it, move with it. So yeah, I don't know that there's going to be much different to see in the solutions, but look through them, see what else you can learn. Otherwise, yeah, hit me up with those questions, or let's get into another challenge. Thanks for watching.